Hi everyone, David Maley here. Today we're going to do something really cool. We're going to do data type conversion in Python, but what we're going to also do is we're going to do some really cool insights based off that, and you're going to end up with some really cool graphs like this one down here and some really cool insights. And today we're going to use a really neat data set. We're going to use the tax info data set from the IRS, which is scrub data, so you can't see who it is or identify these people. So let's get started with this. So today what we're going to do is we're going to do that. We're going to load this into Python. So obviously we're using Python 3 here today. You can see it here, and Jupyter Notebooks. Okay. So we're basically going to start with two libraries in Python. Obviously Pandas, it's probably your most popular library. Their second most popular is probably going to be NumPy. So we're going to call in, we're going to import Pandas and NumPy right here, just like this. Okay. And once you've done that, then you can pull in your data. So our data, let me get this here, is right here. And what's important with this line of code right here is this little R right here. If you don't use this, there's other ways to do this, but basically Python will not find your location for your file. All right, it's a CSV file we're loading in here. So once I do this, once I've loaded these in, right, hit run. Then I just click in here and run this, right? This shows you the exact data that we're dealing with here. Just not, obviously not all of it. This is the first 6 rows. That's what the head does. Okay. Now, when you do this in R, it'll give you, 1 through 6. In this case, it'll give you 0 through 5. That's what Python does. So it's like an array. And so you've got count, household income, household debt level. Are they married? College grads. Average household age, cars, how many cars did the household have, did they file their tax in 2017, 2016, and 2015, and what political party. It's got 3 political parties, right? Democrat, Independent, Republican. That's the data the IRS has. And political party number, which is basically just a number associated to the political party. So once we do that, let's go and look at our data, right? So we've put this with this right here, we put this into data 1, which is our data frame, right? And so if we look at this and we say type of data 1, right? That gives us this right here where it says pandas, core, frame, data frame, okay? Now, if we want to get the type of a column, so it could be anything, in this case we pick HHI, you put data 1, brackets, HHI, and data type. Right, so that's exactly how you would do it, just like this. You hit run, it'll just say this. I'm just showing you how to do it. You don't have to, it's already done here. That's what's nice about Jupyter Notebooks. And then it gives you the type, which is integer 64-bit. Okay. Next, you go to this. Let's look at married, right? Let's take a look at that. Same thing, same thing. Now, the Jupyter Notebooks, you have to understand, some of them jump up and down a little bit, which is fine. So we got it right here, integer 64. Now, if we get all the data types, right, we want all the data types. I don't want just a row. I don't want just the object of the actual data frame. I want all the data types of all the rows. We hit data 1, which is what this is called, the data frame, right, dot dtypes with an S. Okay, so you just hit this, hit run, and this is what you get. And in this case, we have integer 64 for just about everything except for political party. Obviously, because political party looks like a character string, or string, so it will be object. The others are integer 64s. Now, what we're going to do here is we're going to do some changing, right? This is about data conversion. So we want to do data 1 college grads. So let's take the college grads, which is integer 64 right here, and we're going to make it equal to as type float. So see how I do that? Data 1 college grads in brackets dot as type, and then what is it going to be? Float, integer, whatever. Okay, so you do this, right? Hit run. And it also will do this too, the n equals 6. Doesn't matter where I click in here, it does them both when I run this block. And if you look down below here, college grads went from up here where it was just a single digit, right? 0, 3, 1, 2, whatever. Now it went down here to where it's 0.0, right? It's now a float. It's got a decimal. So that's how that works. And again, we use data 1.head, number equals 6, n equals 6, and gives us 0 through 5 to see that. Now, once that we've done that, we want to look at and make it to an integer, right? So let's do this. So we're going to take college grads, which is right now a float, right? Because you can see the decimal right here. We're going to make it into an integer. Now, this is what's interesting. So let's do this. Hit run as type integer, like I just told you was as type float before. Now, when we do this, let's take a look at the data, right? Let's just take a look at it this way. See this one right here? It says integer 32. See that? That's where college grads is right here. And the problem with that is, I mean, it's not a huge problem. By default, it decided it could be a smaller integer, byte size. But let's say I want to set it back to what it is. Well, you can't put integer 64 in here as type because Pandas doesn't work with that. So you have to use NumPy, right? And when we use NumPy, we use NP. So this is what we're going to do right here. We have to use this very similar code. What we're going to do is as type parentheses np.int64. And with NumPy, we can do that. And what this will do, run here, is we will go right here to where's college grad? It's integer 64. Watch, just so you can see it. Run that, dtypes, there it is. It's integer 64. So we're right back to where we were at the beginning. Okay, so we just went through converting floats, integers, and different integer types back and forth. Okay, so now let's go into strings, right? So we have married, and obviously married is 0, 1, or 2, right? But what if I want to make that a string? It could be a string, it doesn't matter. So what I can do is the same thing as I did before, data1 married as type string, right? So if I do this, and I do the head of it, right? Hit run, what we get is we get this, but look at the object type. So married was integer 64, it's now object. Now I can look at it with all the rows like I am right here, or I can do it just by a single column. I mean, all the columns or just a single column. In a single column right here, I can just look at this and it says right here what it is, object. See that? So now what I want to do is I want to look at tuples, lists, and sets because you're going to work with those in data science. You're going to work with those in analytics, and you might work with that in, well, you're definitely going to work with that anyway in programming. So a tuple is a finite list, right? It could be anything. And in this case, I'm going to show you political party because it's a string, right? Political party, as you see right here, it's an object. And political parties, Democrat, Independent, Republican, right? So let's take this and run a tuple on it, right? And what we get is a whole list of just everything in a row. What is it? Democrat, then the next one's Independent, then Republican, Republican, Independent, Democrat. Okay? You will see on this case that list is the same, but now list, keep in mind, doesn't have to be a finite list. It could be an infinite list. Okay? It depends on what you put in. You could put infinite random numbers into something as an example, and that could be an infinite list. But a tuple is finite. It's not infinite. Okay? It's got an ending point. So if I take a list right now, that's going to look exactly the same. See that? Democrat, Democrat, Independent, Republican, Republican, Independent, Democrat for this top, n equals 6. Now, we also have a set, right? So a set is different than both those because a set means what are the unique pieces. So for instance, if I was playing chess, it's not going to give me all of the pawns. It's going to give me one pawn, one king, one queen, one bishop, one rook, and so on. Okay, so in this case, with political party, we know we got 3 in this case. We have Democrat, Independent, Republican, right? That's the data the IRS has. So if we run the set on this, you hit run in this box. Right here, you see Democrat, Independent, Republican. That's it. You don't get anything more than that because there's nothing more in there. That's it that's in there. Now, if we just run the unfiltered data set of this, okay, and we wanted to look a little bit more into it, maybe represent something with a graph here. Well, the problem here is, look at this. If I put plot.scatter, data1, household income, data1, political party, right? So I'm going to put political party up against the household income, right? You would think that might show you something. In this case, it does, but it shows you that they're very well represented at both points, up to $300,000 down to 0, right? Whether it be Republican, Independent, Democrat. They're both all very well represented. Republican might have a smidge more people at the upper end. Independent has a little bit less right here where I'm pointing the arrow. There's a couple little indentations here. And then Democrat might have a few less right here. But overall, they're very well represented against all 3. So you really can't tell anything with that. So let's take it a little bit further, right? This is where we use filtering with this data conversion stuff. So we're going to add a little bit of filtering here. And what we're going to do is we're going to take, whenever I filter something, I like to take, let's take this off here so it doesn't go and do something wrong here. Let's look at this. I've got data 1 here, but see how I put it into data 2? Whenever I filter something, I would like to leave the original data alone. And so what I'll do is I'll put my filters like this, and then I'm going to put that into data 2, right? So I've got here data 1, this is how it works, brackets, and the column that you want, right? In this case, household income less than 85,000, household debt level greater than 10,000. So somebody that's got less than $85,000 in earnings has, 10,000 or more in debt, and that they did not see this less than one, they did not file tax returns in 2017, 2016, or 2015. So obviously someone that's probably a repetitious non-filer, right? So in this case, if I run all that and I put that data to, okay, now I've got data to filtered down, so I'm not showing everything here. I'm fine-tuning to a certain group of people. And in this case, once I do that, then I can use this right here, the plot.scatter, right, of data 2, right? So I'm using data 2. If I use data 1, I'm not going to get this filter. I'm going to go right back to this, okay? And I use bringing all the data 2 fields that I want. So I've got data 2 household income, data 2 political party, and then I've got the color equals household debt level, okay? And then I've got multiple things I can get insights from here. And then I've got the size equals average household age, and the alpha is 0.5. And so if I do this, and I use plot.colorbar, which gives me the bar on the side, the legend. I use plot.title and plot X and Y labels, so I can make my graph a little bit more pleasing. And when you do that, you end up with this graph right here. And what's interesting here is based on this data, now keep in mind this is not all the data. Remember, we filtered it down, so we're not using people like that have earned over $100,000 a year. We're not using people with less than $10,000 in debt, taking that out. So in this case where we're just using what? People that earned less than 85,000, people in their household, remember that, that's not per person, it's for their household. Their household debt level is greater than $10,000. Yes, the IRS has access to your bank records and stuff like that. And then people that did not file in 2017, 2016, 2015. Keep in mind, they could have filed in 2018. They could have filed all three of them in 2018 and 2019. That's not here. It's just 2017, 16, and 15. Okay, so based on that, we have this data right here, which says we have one Republican person. And remember, what is it? The size. See how it's a bigger circle? So the size is an older person, right? So that's generally an older person that did not file their taxes. We have Democrats. We have a plethora of them down there. But we have different age ranges. So if you see, they have a lot of little circles in here. So you have a lot of younger people. And you would have to go and plot that out to see what exact age range that is. But I'm going to guess it would be somewhere in the 30 to 40-year-old range. And this is probably a 50-plus range. But you do have, so it's no different, you do have Democrats that are of that age, two of them right here, rated about 78,000 that didn't do their tax returns. You have the Republican here, and you have independents. You have three independents that are probably 40, 50, 60 years old right in here that are lower earners that did not file their tax returns. Now, it doesn't give you the whole story. You do have people that are independents that did file their tax returns, that did earn more money or had different debt levels, and they would not show in here. So that's why that's blank there. But if I filter it just to those groups, what I end up here, the story is that for this Republican here, that's probably a 50 to 60-year-old non-filing taxpayer for 3 years, you have 3 times as many independents, but they tend to earn less. See that this guy was probably about 70,000. These guys are 20,000 and under. Now, keep in mind, these guys down here on this end may not have had to file tax returns. So, the IRS has some rules. I don't know exactly where the cutoff is. Some of these guys may not necessarily belong on this list. Then we could have put that in filters if we figured that out. Now, from there, we have the Democrats, and they're 12 times likely. You get 12 dots in here as the Republican in this age range with this specific, well, not necessarily age range, but in this specific grouping of income, household debt level, and not filing taxes to be in this group. So there you can look at it from this, based on this data, okay, and we're not saying Republicans any better or Democrat better than independent. I'm just telling you what we found here is that with the IRS data, that Democrats at this end of the household income level and household debt level tend to not file their tax returns 12 times more likely. That's all we're saying here. That doesn't mean that they do. It just says the data shows that. But anyway, back to this. So what we've done is we've taken you from bringing in the data, bringing in the libraries, looking at and converting things back and forth. We looked at different data types, and then once we did that, we looked at the overall data types, converting back and forth, how to do special factors, like when it goes to a default of the wrong data type as an integer 34, and you want to get it to integer 64. Then on top of that, we went and looked at tuples, lists, and sets, and why they're important. And a set obviously will give you the unique conditions or factors or results for a column, versus the other two will give you a finite or an infinite list depending on which you select. Then we went and scatter plotted did a scatter plot with the data. The first one was for the full data, data 1. It doesn't show you a whole lot of anything because we got great representation throughout each of the ranges, incomes, everything here. Well, we didn't do everything, but we did household income by political party, so by household income. Then when we started filtering out these people and figured to get to household income level below 85,000, data or debt level, household debt level greater than 10,000, and non-filing in 2015, 16, and 17, then we ended up with this graph right here, which is kind of interesting. Now, this could have been different data. It could be something else, but it shows you what you can do with data, with Python, and with Jupyter notebooks, and with some data conversion to go and cleanse your data, change your data to what you need it to be to better represent what you need to show. I hope you found this interesting and informational. We've covered a lot of stuff here. Take a moment to like, subscribe, and please click that bell so you'll get notified every time I come out with a great video like this that'll show you and teach you how to do different things we do in data science and data analytics. Thanks again for watching, and have a great day.